Welcome to our competency-based question series designed chapter-wise to strengthen your conceptual learning. And question 11 says a loop of area A carrying current I is placed in some external magnetic field B. It experiences a torque. We need to comment on the direction of the torque with respect to the plane of the loop. So the torque on a current carrying conductor in a magnetic field, it is given by M cross P, where M is the magnetic moment and B is the magnetic field. The direction of magnetic moment is along the area of the loop. So this will give us the direction of torque will always be in the plane of the loop. When we do the cross product of magnetic moment and magnetic field, the direction of torque will always be in the plane of the loop. So with respect to the plane of the loop, we can say that torque will always act in the plane of the loop. Let's take part B as well. Can the loop rotate around itself like a spin wheel due to this torque? No, it cannot rotate as the torque is acting in the loop. For the spin wheel to be rotating, the torque must be acting along the vertical axis through the loop. But in this case, the torque is acting in the plane of the loop, so it will not rotate like a spin wheel. So we can answer it like this. For the loop to rotate around itself, it requires a torque that is along its vertical axis. But in this case, the torque is along the plane of the loop. So the loop cannot rotate like a spin wheel. Now, let's take part C. What is the shape of the graph between torque and theta when the theta varies between 0 to 180 degree? So we know torque tau, magnitude wise, it is mb sine theta. At theta is equal to 0, tau is equal to 0, and at theta is equal to 180 degree, again tau is equal to 0. At theta equal to 90, torque is maximum. Sine 90 is 1, so torque will be mb only in that case, and it will be maximum. So we can draw a graph like this. At theta equal to 0, it will start from 0, attains a maximum value at theta equal to 90, and then again come back to 0 at theta equal to 180 degree. And that is the answer for part C. Thank you for now. Keep learning, keep practicing, keep